everyone, my name is Anuja Balaji Erode from SYB AIDS branch. So the today's topic is measure of spread. So now we start the topic measure of spread, understanding data variability. This presentation explores measure of spread critical for understanding data variability, well delved into different matrices and their real world applications. By the end, we will grasp how these measures enhance data application. Now we start about the measure of spread. Measure of spread means understand measure of spread is a key to understand how much your data values differ from each other. They show how spread out the data is helping you interpret the consistency and reliability of the data. This is called as a measure of spread. Why measure spread? Introducing range and interquartile range. So first is why measure spread. Measure of spread shows how data points differ. They complement averages, provide a full data picture. Understanding variability is a key. Means while measure like the mean or median tell us the center of a data set, they don't show us the how the data varies, that where measure of spread come in. So this is the measure of spread. Range. Range is the difference between the highest and lowest value. It is simple but sensitive to outliers. Means the range is the simplest measure of spread. It tells you the total spread between the smallest and largest value. Interquartile range. IQR covers the middle 50% of data. It more robust to outliers than range. Means the interquartile range of spread of the middle 50% of the data. It is more reliable than the range when dealing with skewed data or outliers. The standard deviation, a deeper dive into data dispersion. Common measure. Standard deviation is widely used for spread. It measures data dispersion around the mean. Means in that we can take the range total between the smallest and largest value. So this is the meaning of common measure. So the next one is the average distance. If quantifies the average distance of each data point from the mean, a larger value mean more spread. Means in statistics we usually mean how far on average each data point is from the mean of the data set. This helps us understand how spread out or consistent data is. So this is the meaning of the average distance. Normal distribution. It's especially useful with normally distributed data. It helps define data cluster. Means the normal distribution is on the most important and widely used concept in statistics. It often called the bell curve because of its shape. A normal distribution is a symmetrical bell-shaped curve. We see in the diagram, this is the bell-shaped diagram of the Calculating standard deviation, a step-by-step guide. Find the mean, sum all data points and divide by the count. Subtract the mean. Subtract the mean from each data point. Square the differences. Square each result from the previous step. Sum the squares. Add up all the square differences. Divide by n minus 1. Divide by the numbers of data points minus 1. Take square root. The final result is the standard deviation. Variance, the square of standard deviation and its implications. What is variance? Variance is the square of the standard deviation. It measures how far data points are from the mean. Y square 8. Squaring difference makes all values positive. It also emphasizes larger deviations, giving them more weight. Interpretation. A larger variance means data is more spread out. It often used in statistical tests. It helps understand data distribution. Standard deviation versus IQ are choosing the right measures. Standard deviation. Best for symmetrically distributed data. Sensitive to outliers. Considers all data points. More information for advanced analysis. Like sensitive to outliers. Uses all data. Good for normal data. Interquartile range. Ideal for skewed data or weak outliers. Focuses on the middle 50%, less sensitive to extreme value, easier to compute manually. Like robust to outliers uses middle 50%, good for skewed data. Visualize spread, box plots and histograms. Histograms. Histograms shows the distribution shape. They display data frequency in bins. You can see central tendency and spread. Box plots. Box plots, box and whisker plots display 5 numbered summaries. They clearly show median, quartile and outliers. Very useful for comparison. Combined insight. Using the provide a comprehensive view, histograms shows overall shape, box plots detail, summary, statistics. This combined approach is powerful. We can see in that graph there is a histogram and then you can see there is a box plots also. Practical applications and takeaway measuring spread in real world scenarios. 3.5% stock volatility. Standard deviation measures stock price volatility. High values indicate higher risk. Low values indicate stability. It's a key finance metric. 10 mmHg medical readings. IQR helps analyze blood pressure variability. It identifies consistent patient health. Outliers might indicate issues. Used for treatment success. 2 hours. Quality control. Measuring production times with standard deviation ensures product consistency, identifies process influences key for manufacturing quality. So thank you for watching this video. Thank you so much.